Hello everyone, welcome to Gatewala and welcome to compiler design subject. So how are you all? Okay, let us continue with compiler design syntax analysis topic today also. So in our last lecture, we have discussed about how to design a syntax analyzer or parser by using top-down parser. Top-down parser. Okay. Hello everyone. Welcome. How are you? Right. Today also our discussion is on parsing, but we have a other type of parsing algorithm that is called as bottom-up parsing. So our discussion in today's session is on bottom-up parsing. So before going to start this, so just let us recap what we were doing, what we were studying in these lectures, what we studied in a previous lecture. So we are in the design of syntax analysis. Syntax analyzer, which is also called as parser. So to design this parser or syntax analyzer, mainly we have two type of algorithms. So in our last class we were discussing about there are two type of algorithms, namely top-down parsing algorithms, top-down parsing algorithms. This thing we discussed in the last class, and bottom-up parsing algorithms. There are like this. To design a parser, we have two type of algorithms: top-down parsing algorithms and bottom-up parsing algorithms. Okay. So in the last class even we discussed which is the more powerful one in this. Out of these two algorithms, which algorithms are powerful? I think this discussion also we did in the last class. So out of these two, top down and bottom up. In the top down, the what we discussed in the last class is the most important one, that is LL1 parsing algorithm. LL1 parsing. So this is what we discussed in the last class, and we have constructed even the parsing tables. Okay, right. So bottom up parsing algorithms are the most powerful algorithms compared to the top down parsing algorithms. So in the bottom up parsing we have different varieties. So in today's discussion, so in today's class, our discussion is completely on bottom up parsing algorithms. Bottom up parsing algorithms. In the bottom up parsing, mainly we have two things: LR parsing and operator precedence parsing. LR parsing, operator precedence parsing. These are the major two parsing algorithms which are available in the bottom up parsing algorithms. Out of these two, the most important one is LR. So, and more powerful one also LR. So we will discuss anyhow both of this in this bottom up parsing algorithms concept. So this is what the major parsing algorithms which are available in the last class. So I have shown you the general type of parsing algorithms: top down, bottom up. So in the top down, the most important one is this one. So that's why we discussed even this one in the last class, and today we are going on this bottom up parsing. For gate point of view, for gate examination point of view, out of these two, which is a more important is LR parsing is the most important one. Here for gate point of view, so because our discussion is mainly on gate point of view, so we are focusing from this LL1, from here LR. Operator precedence is also important, compared to LR less important. That's why whenever you are doing preparation, that too in this small amount of time, so where we have to focus more and which topics we have to focus more. So here from top down we have to focus more on the LL1 parsing that we have studied in the last class already. From bottom up parsing we have to focus on LR parsing. Okay, right. So okay, so let us start constructing parser by using bottom up. What is the bottom up method? how the bottom-up method works, and what are the working style of bottom-up parsing algorithms, different terminologies. All these things we are going to study in today's class. So I hope before going to start this, so these are the two type of parsing algorithms. Bottom-up parsing, top-down parsing. This is the most powerful one. This is what we are discussing in the today's session. And before going to that, so I hope every one of you remembered this syntax analysis, what exactly syntax analysis and what exactly parsing is. Once again, parsing means same thing. In yesterday's class, even in top-down parsing, we did the same. Whenever we say parsing, whenever a terminology, parsing, if you say parsing, just one thing, one string, one grammar, the string is member of the grammar or not, that's all. A string is generated from given grammar or not, that string is member of given grammar or not. Parsing is this much a very small concept, but in order to make that parsing in a efficient way, or in order to make a program for that, these many type of algorithms coming into picture. Okay, so that's why the syntax verification we are doing, structure of the program. In order to do this, we are trying to develop the program, that is parser. So here two methods are there, top down approach, that LL1 that we discussed in last class, and bottom up that we are discussing in today's class, right? If the tokens are members, parser produces parse tree output, otherwise syntax error. It is a program that takes tokens and CFG as input. Tokens are members or not, verifies. Right. Let us see the working style of the bottom-up parser. How initially it works. First, the major difference between top-down parser and bottom-up parser. Three differences we identified. First one, tree construction. Top-down parser constructs tree at the starting symbol and proceeds towards the given string. So that is what we have seen in the last class. Starting symbol to given string. The construction top to bottom happens. But whereas in bottom-up parser, it is completely reverse. Bottom-up parser constructs the parse tree. Beginning at the leaf nodes. Bottom leaves. And working up towards the root. So from bottom to top. So that way of construction itself different. Complete the method is different. That's why bottom up method of construction of parser is completely different approach. We'll start at the given string and we'll try to get the starting symbol. So bottom to top the construction is going on. That's why the name bottom up parser. This is the first difference between a top down parser and bottom up parser. That is what we have seen this one in the last class as well. What is the second difference? The second difference is the derivation. So what type of derivations normally we are using in the top-down parser? Tell me. I think we discussed in the last class. What type of derivations generally we use in the top-down parser? So top-down parsers generally uses leftmost derivations. Top-down parsers generally uses leftmost derivation. Whereas bottom-up parsers uses rightmost derivation. Derivation is also different here. Rightmost derivation in reverse order. Okay, we'll see that how it is happens. So these are the points of these two are the major important points that we have to learn from this. Yes, definitely top-down parsers leftmost derivation, bottom-up parsers rightmost derivation in reverse order. Remember this. Through example, we'll see how this rightmost derivation happens and all this. But bottom-up parsers in which rightmost derivation is happened inside. So RMD in reverse order. That is what happening in the. So first different, tree construction is different in both. Second one, derivation is also different. Third one is a power. Top-down parser is less powerful. Bottom-up parser is more powerful. These are the three major differences out of top-down and bottom-up parsers. Anyhow, bottom-up parsers are more powerful one. So we'll see the working style of bottom-up parser. How a bottom-up parser performs parsing. What is parsing generally? Once grammar is given, if one string is given, the given string is generated from given grammar or not. In top down, we'll construct the tree structure, we'll verify. In bottom up, how? Let us see the working style of the bottom up parser. Assume I have a grammar like this. This is one of the grammar given. And here one input is, there is an input. This is the input. Now I have to verify whether this input is generated from this grammar or not. This concept is called as parsing. Verifying this string is generated from this grammar or not. So verifying whether a given string is member of given grammars or not, that is called as parsing. Generally, that is a concept of parsing. So if it is bottom up parsing, how? So bottom up parsing, see here, the construction of tree structure is like this. Bottom up parser constructs parse tree from like this, bottom to top, bottom to top. Okay, and the way of construction is like this. First, to check this string is member or not, we will take the input string. We will take the input string, and in the input, this is the main concept. To verify this string is member of the given grammar or not, we will take the input. In the input, any substring that matches with grammar right hand side part. So bottom up parsers always concentrating on grammar right hand side part. Grammar right hand side part is the main important thing here. So in every step, what happens? Any substring from the input that matches with the grammar right hand side part or not, it observes. If any substring that matches with grammar right hand side part, then corresponding left hand side non-terminal will be replaced. So the major difference between top down parser and bottom up parser is, this is one more difference you can identify, the way of doing parsing. In top down parser, we'll take a non-terminal, left hand side non-terminal replaced by its right hand side part. Left hand side non-terminal, S will be taken, S will be replaced by its right side. That is happening in the top down. But whereas in bottom up, we'll observe the right hand side. Right hand side is replaced by left hand side. See how much difference. Completely different approach. That's why in every step, whichever the substring that is matching with grammar right hand side part, we'll observe. Whenever any substring matches with grammar right hand side part, corresponding non-terminal will be replaced. So let us see here. In this input, can you observe just up to this part? Can you observe what is the substring that completely matches with grammar right hand side part? Did you observe anything? Any substring, it has to match completely with grammar right hand side part. The substring of this string should match complete right hand side part. Is there any, did you observe anything like that in the first step, the step 1? Any observations? Yes, we have a substring that is B. Look at this. B completely matches here. Substring in the input completely matches with grammar right hand side part. Whenever the match happened, corresponding left hand side non-terminal will be replaced. So this B will be replaced by A. Yes, very good, very good. So this small b will be replaced by capital B. Okay. This is the only concept we'll follow throughout the bottom up parsing. At every step, same concept. At every step, same. In the second step, now we are in the second step. Now any substring which matches with the complete grammar right hand side part, just observe it. So at every step, same. Matches with right hand side part happens or not, verify. It is just a string matching concept. The substring, look at this, ABC completely matches here. If match happened, left hand side non-terminal will be replaced. So parsing is a systematic process. Parsing is a systematic process. So by using some particular approach, a program is doing this. The approach is, if it is bottom up, it is like this. This is the approach. The third step, what is matching the third step with grammar right hand side part? Look at the symbol D here. D. D is matching, replace it by B. The fourth step, matching with S. So in this process, if we get the starting symbol, given string is member, given string is member, parsing is success, valid syntax. Like this, bottom up parser will perform parsing. So the major concept, the core concept of bottom up parsing is to verify given string is member of given grammar or not. That is called as parsing. That means to perform parsing at every step, bottom up parser is doing only one thing. That is any substring matching with the grammar right hand side part or not. If the substring matches with grammar right hand side part, its left hand side non-terminal will be replaced by that substring. So here B is matching, replaced by A. Second step, ABC is matching, replacing by left hand side non-terminal A. Third step, D is matching, replacing by capital B. In the fourth step, this is matching, replacing it by capital S. Like this, at every step, any substring matches with grammar right hand side part, left hand side non-terminal will be replaced. Okay, this is the way. And see the tree construction. Whenever this replacement happens, parallelly parse tree is also constructed. So the parse tree construction is like this. This is replaced by this. B is replaced by capital A. Tree node is constructed. Then ABC. So A from here, B from here, C from here. Tree node is constructed. Third step, D will be replaced by B. Tree node is constructed. Fourth step, A, this one, B, E. Total S is constructed. So this is the way tree construction. Tree construction started at here, given string, started at the string, that is bottom, and going towards starting symbol. Starting symbol, bottom to top. That's why it is called as bottom up parsing. Bottom up parsing. Okay. So this is the working style of the bottom up parsing. Right. So I am saying manually the substring that is matching with grammar right side. For this, we have specific terminologies in the parsing, that way especially in the bottom up parsing. So whatever the thing I am saying here, these concepts are called as handles. Handle. So let us slowly move into the terminologies of bottom up parsing. In the bottom up parsing, we have a major concept called as handle. No need to recognize end of the string. We don't have null character, not required. No need to have the null characters here. So to recognize end of the input, this is a manually I am explaining now. Whenever we put this in a systematic way, in program way, how the program looks like, that is called as LR parsing. I'll tell you how to recognize that will be by using this. I mean, CSC AML student, can I appear get? Yeah, why not? Definitely. CSC AML student, you can appear and get. Some students are asking doubt. Raghunathan, you can appear for GATE. In which year of BTech? You are in which year now? Any third year students can also appear. Yes, you can appear for GATE. I am saying. Right. See here. Whatever the previous concept, the main concept of bottom up parsing is handle detection. First year students cannot appear for GATE. If you are in third year or above that, fourth year, then you can appear for GATE. First year, it's not. Right. Okay then. Let us focus on this. In bottom-up parsing, we have one more thing called as handle. Handle. What is this handle? It's very simple. Whatever we studied till now, this is a general question we can expect. We got in GATE papers many times, because the main concept of bottom-up parsing is handle detection. What is the handle? Handle is nothing but substring. Till now, whatever I am saying substring, the substring that matches with grammar RHS, GRHS. That is our handle. Simple. Still now, I am not using the perfect terminology here. Still now, because we are going in a manual way. Perfectly, if we use the bottom-up parsing terminology, we can say like this. Bottom-up parser will do parsing by detecting handle at every step. So in the first step, what I am saying, the substring B is matching, so replaced. Now we can say the same thing like this. In the first step, B is handle. Handle is nothing but simply previously I am saying in normal terminology substring. That substring whatever is matching, that is the handle here. So in the first step, the handle is nothing but B. In the first step, handle is B. Like this, can you people tell me what is the handle at the second step? What is the handle at the second step? So what the bottom-up parser will do, at every step, it detects handles. At every step, it detects handles. What is handle? Substring matching with grammar right side. For this total terminology, a beautiful word is given, that is called as handle. Very good, very good. The handle at the second place is ABC. So what the bottom-up parser will do, whenever a handle is detected, that handle is replaced by its left-hand side part. That is called as reduce. Handle is reduced, this much of big thing, reduced to a non-terminal. Handle is reduced to non-terminal A. So these are the basic terminologies. So handle detection is the major concept here. Okay. So in the third step, what is our handle? In the step 3, what is our handle here? Step 3, what is our handle? So we have a D here. This is the substring. So handle is D here. Handle is D. In the fourth step, this total thing is the handle. So fourth step, like this. If we in this process, so the bottom-up parser will perform parsing by detecting handles at every step. Whenever a handle is detected, replacing by non-terminal, that is called as reduce. Handle is reduced to non-terminal. Handle is reduced to non-terminal. Handle is reduced to like this. Like this, the total input is reduced to starting symbol. Given string is member. Parsing is success. So this is the exact concept of bottom-up parsing. So like this, there is a possibility of getting question, many times asked question from this like this. Whenever we are doing bottom-up parsing, how many handles detected by bottom-up parser? So assume we have something like this. How many number of handles detected by bottom-up parser for the following grammar and input? Same grammar and same input. Now tell me for this, how many handles are detected here? How many handles detected by bottom-up parser for this grammar, for this input? This is the grammar, this is our input. How many handles? What are the number of handles? This is the first handle which is detected. This is the second handle, third handle, fourth handle. That's all. 4 number of handles detected like this. So bottom up parsing is nothing but very easy one. Detection of handles. Detect handle, reduce to non-terminal. Detect handle, reduce to non-terminal. Detect handle like this. Whenever you are doing bottom up parsing, how many handles a bottom up parser detects? This is the first thing, first question you can expect in the gate paper from this bottom up parsing concept. Okay, is it clear this part? So handle concept is a major important one, right? Whenever we are using this handle concept, and if you observe in the derivation point of view, if you see in the derivation point of view, look at this. Derivation means we have to start from this side. First, see this in a reverse way. First this is replaced, then this is replaced, then this is replaced. This represents a rightmost derivation. If you go in the derivation point of view from starting symbol onwards, if you observe this, it is nothing but a rightmost derivation, but we are doing in reverse. That's why we use the term bottom up parsers. Using, you take any LR parser, any operator distance parser, the concept is same. That's why simply we use bottom up parsers using rightmost derivations inside. This handle concept, whatever is there, that will give us rightmost derivation, but in reverse way, because we are going on reverse way. That's why see this bottom up parser using rightmost derivation in reverse order. Top down parsers, leftmost derivation directly, but inside bottom up parser, rightmost derivation is there, but we are doing it in a reverse way. Whatever our handle concept, the handle concept, if you implement in a bottom up parsing, that gives us a rightmost derivation, but we are doing in a reverse way. That's why the terminology we used is bottom up parsers are using rightmost derivation, but in reverse order. So these are the points. So now we got how the tree is constructed in bottom up manner, string to the starting symbol, rightmost derivation. Then we use handle. Bottom up parser performs parsing by handle detection. Handle detection is the major concept and main concept in bottom up parsing, right? So whenever we see any input, then we should be in a position to give handles. See, here we have a grammar here, and I have an input ZZ. Now, how many number of handles detected by? How many number of handles detected by bottom up parser for the following grammar and string? Assume this is the normal question. Normal question, easily we can expect. So whenever a grammar and input is given, we should be in a position to identify number of handles. That means how bottom up parsing is performing. So let us do. All of you please try from your side, and even I am also explaining here. Take the input first. This is our input. This is the grammar. In the first step, let us go by this. Can you identify which is the handle in the first step? So handle detection is the only main concept. If you know this, LR and everything will becomes very easy. Handle is the major and very important concept of bottom up parsing. So here, what will be the handle in the first step? What is the substring that completely matches? So simply, this is nothing but Y here. We have to read from left. Y. Y is the completely matching thing. So replace it by yes. Replace it by S. In the same way, what is our handle at the second step? In step number 2, what will be the handle at step number 2? The substring, that substring completely matches with grammar right side. So this is the substring completely matching here. So it will be replaced by SZ, replaced by W. This is our third step, step number 3. Very good, very good. At step number 3, which one looks like a handle? Which one is the handle? Which one is the handle? The substring that completely matches with grammar right side. This one. So it is matching here. Replace it by yes. Very good, very good. In the step number 4, which one is a handle? SZ, SZ. Replace it by W. Step number 5, directly yes. So how many number of handles? In how many steps we are doing? First step, this is one handle, 2, handle 3, 4, 5. So total how many handles detected by bottom up parser? Total 5 handles. 5 handles detected by bottom up parser. Clear? So like this, whenever we are doing bottom up parsing, the way of detection of handles is this way. The substring that matches with right side corresponding left hand side non-terminal, and this should give us definitely starting symbol. Whichever is the producing starting symbol, those substrings are generally called as handles. Like this, every bottom up parser is doing in the same way. So at every step it takes string matching only. Take every step, and these steps are called as sentential forms. So at every step, matching the substring with grammar right side, whichever is matching handle, replace it by corresponding non-terminal. Okay, right. This is the normal bottom up parsing one can perform. Okay, I'm giving some homework question here, so you can take this as handle. This is a grammar, and this is our input. How many handles detected? Just you can practice how many handles detected by bottom up parser by using this and this. Handle detection is a major thing because this is the only concept by which we can perform bottom up parsing, right? Now same concept, whatever the concept, now I am doing bottom up parsing in a manual way. Manual, this is called as bottom up parsing manual way. Same thing, whatever we perform now bottom up parsing, for this if you want to program, if you want to write a program, however we performed bottom up parsing manually, for the same thing, total thing, if you write a program, how this program looks like? The program looks like this. This is called as shift reduce parsing. Shift reduce parsing. Shift reduce parsing is nothing but bottom up parsing in a systematic way. Performing bottom up parsing perfectly in programming point of view. So whatever we did, we are doing bottom up parsing till now manually. Like this, if a program has to do this process, that program is called as shift reduce parsing. All the bottom up parsers, whatever it may be, LR parsers, operate, every bottom up parser is shift reduce parser. Okay, why it is called as shift reduce parser, I'll explain. What is shift reduce parser? The shift reduce parser is like this. It is having a stack here. One stack is there, and we have an input buffer. All the input buffers contains tokens. Tokens. Okay. So whatever the token list, what is syntax analysis? The tokens which are coming from lexical analysis, they are syntactically correct or not, they are in proper order or not. That is what we are verifying here. That is called as syntax analysis. For that reason, all the tokens store in the input buffer along with $is end marker. Previously, some of you asking, sir, how to know where is the end of the input? Now, the end of the input indicator is $here. $here. Okay. So we'll store all the tokens which are coming from lexical analyzer in a buffer, and end of the input as $. Okay. And we need one stack here. One stack data structure is required. We need to take a stack data structure. This stack data structure is for the purpose of detection of handles. Till now I am saying match this, which is handle. So if we want to do that handle detection concept, we want help of stack. So one stack is there, input is there. Then this total is our parsing algorithm. What this algorithm will do, it will perform push pop operations. It will push some symbols into the stack and detects handles. Whenever a handle is detected, replace it by non-terminal. Like this is the way it is going on. So assume I have a grammar like this. First symbol A is pushed into the stack. Symbol A pushed into the stack. And verify this is handle or not. This is handle. Replace it by non-terminal capital A. This is called reduce. Like this, in shift reduce parsing, generally what are the things which are there? Just read it once. Shift reduce parser attempts for the construction of parse tree in smaller manner as done in the bottom up parsing. Parse tree is constructed from leaves to the more general form of shift reduce parser is LR parser, requires some data structure, that is stack. Some data structure. Okay. We have here. So input buffer for storing the input string, stack for storing and accessing the production rules. So this is the general structure of shift reduce parser. If it is LR parser, also same. We have two parsing algorithms, LR parsing, operator precedence parsing. Both are shift reduce parsing. Whenever you say shift reduce parsing, the structure is like this. Okay. Now we'll see what is this shift and what is this reduce. So when we are saying a operation is called as shift, and when we are saying operation is reduce. See here. Here stack operations only, basic stack operations. Generally we are saying push. But here in parsing terminology, in compiler terminology, we'll use different name, because along with the push we have some other small basic operations. That's why together we'll call it as shift. See what is the meaning of shift here. In every shift reduce parsing, we have four terminologies. We have four operations: shift, reduce, accept, error. In all bottom up parsers, we have these four operations: shift action, reduce action, accept action, error action. So what are these? Before going to start the bigger one, LR parsing and operator precedence parsing is very bigger things and most generalized forms. So before starting this, we need these basic informations, basic terminologies. What is shift? Just see this. Shift is, this involves moving of symbols from input buffer into the stack. input buffer to stack. If you move this, any symbols from input buffer to stack. So assume this is the symbol in the input buffer. If I am moving this one to here, this is called as shift. Normally you say push operation, no? Generally we say push operation. The push operation is similar to shift. We cannot say push here, shift. Okay. Right. Now tell me, assume I have something like this in the stack. If I have A in the stack, is it a handle? Whenever A is there in the stack, is it handle? Small a, is it handle? With this grammar, try to identify with the given grammar. Assume this is the grammar. This is the grammar. Assume I have A. Is it a handle? We know meaning of handle already. We know the meaning of handle. Small a is handle or not? Let us perform manually. A, B is my input. A, B is the input. First A is handle replaced. A is handle, no? Matching. Yes, A is handle. A is handle. Okay. Whenever handle is there, handle is replaced by which symbol? Tell me. Handle is replaced by which one? This is the common thing. Whenever we have handle, handle will be replaced by left hand side non-terminal. It's non-terminal. Replaced by its non-terminal. Okay. This is called as reduce. That's all. Nothing will be there. So whenever we have a handle, this handle will be replaced by its corresponding non-terminal. So I am replacing small a by removing small a and this. Yes, it's non-terminal. This is reduce. So you got the meaning of shift. Shift means push symbols from input buffer to stack. So we got the meaning of shift already. Shift is involves moving of symbols from input buffer onto the stack. Input buffer to stack. Buffer to stack. This is shift. Handle. If handle appears on the top of the stack, its reduction is done by using appropriate production rule. Whenever a handle is there, then reduce will be performed. Accept. Now understood the meaning of reduce? Reduce is very simple. Whenever we have a handle, replace it by non-terminal. That replacement is handle. Next we have a handle here, B. This is replaced by reduced. Now we have to say reduce now. Shift reduce. These are the terminologies we have to use. Then this will be replaced by yes. And in this process, if the input is ended and stack contains starting symbol, this input is ended, input is points to dollar and stack contains starting symbol, we will call accept action. So that is our accept. What is accept here? If only start symbol is present in the stack, and input buffer is empty. Input buffer empty means dollar, it points to dollar. Then parsing is called as accept. So parsing action is called as accept. Then it is accept. When accept action is obtained, it is the meaning of successful parsing is done. Okay. Error. We have one more thing called as error. This is what actually our syntax error. This error indicates syntax error. This is a situation in which parser can neither perform shift action nor reduce action. It cannot perform anything. Shift or reduce, nothing will be performed. Parser will halt without successful parsing. That leads to error, syntax error. Okay, like this. If I write a program in this way, this structure of the program. See now how I am manually detecting. First symbols I am shifting from the stack. Tokens, whatever the tokens are there here, shift into the stack. I am using the direct terminology, I am not saying push pop operations. Shift tokens into the stack one by one. whenever you are shifting any token, then verify whether it is handle or not. If handle, reduce. If there is no handle, the way of doing bottom up parsing, shift reduce parsing is shift reduce parsing, very simple. If handle is there, reduce. Handle is not there, perform shift. Like this, majority of the actions of shift reduce parsing are shift and reduce. Shift the symbols, shift tokens, verify for handle. Handle is not there, shift action. Handle is there, reduce action. Like this, shift reduce continuously happening. Finally, if it is a valid input, valid syntax, it will say accept action. For invalid input, error action. Like this, with the help of these 4 actions, will perform shift reduce parsing. Any parser, whether it is a LR parser, operator precedence parser. We have 2 type of parsers in bottom up parsing: LR parsing, operator parsing. Both are in the by using same with the help of 4 actions. See, input string always tokens. Our tokens are nothing but all terminals, sequence of terminals. Non-terminals presents only in the grammar. It is not in the our token sequence. Input will be collection of terminals. Okay. Let us perform. See here, we have a grammar. One example here, we have a grammar like this. And perform is saying perform shift reduce parsing for the input id plus id star id, and we need to count. After performing like this, we need to count how many shift actions, how many reduce actions taken by the parser. So I have a shift reduce parsing here, the basic simple shift reduce parsing. Let us just try to understand this, how a shift reduce parsing is performed. Okay, this is the input. This is the input. See the input here. Input is all collection of set of terminals. Input never contains non-terminals, which is there in the input buffer stack. First one, shift reduce parsing, normal shift reduce parsing like this. If there is no handle, perform shift action. Here nothing is there in the stack, so first perform shift action. This is shifted into the stack. So we have input. I am writing this input here. S is equal to S plus S. S gives S star S already. This is the grammar. In the second input, is there any handle? In the second input. So first we perform shift. Second input. In the second step. Is there any handle? Yes. ID. Matches here. Look at this. Matches here. Matches with this. Replaced by S. That is reduce. Reduce like this with the help of this. Right. In the third step, there is no handle, so perform shift. Plus will be shifted. Now look from the top. There is no handle. Again perform shift. Now in the fifth step, this is the handle. Reduce. Reduce to S. Like the shift reduce only. Next, the sixth step, again perform shift. Then ID will be shifted. Shift. There is a handle. Reduce. Right. Next, these two matches here. Reduce. This one matches here. Reduce. So now stack contains starting symbol, input is $. here S plus is there, but we are performing shift action. Even you can do the reduce also here. Reduce also possible, but we are doing shift here. Anything. Okay. So this is the situation why it will come. So I'll explain in the next coming classes. Yes, in the sixth step, we have reduce. We can do shift and reduce. These are called as shift reduce conflicts. These situations are called as SR conflicts, shift reduce conflicts. Yes, very good. So there are two possibilities. We can reduce, we can shift. Here I am taking shift action because of in order to achieve something. There is some reason behind this. By this time, it is very difficult to understand at this stage. Please wait until LR parsing. I'll explain you clearly in LR parsing what is the reason in order to take shift action here. Okay. You can do by doing reduce also. You can do by doing reduce. But in this example, I have a particular reason in order to take shift action here. If you take reduce, that is also correct. If you perform reduce, that is also okay. What you people will do, you do reduce, you solve this question by taking reduce, then also string will be accepted, nothing will happen. Okay. So like this is the normal shift reduce parsing. Whenever you are doing normal shift reduce parsing, your observation is correct. These type of situations comes. Shift reduce, both possibilities are there. Which one to take? So that is that is a confusing point for a normal shift reduce parser. So to avoid these situations, we have to definitely use LR parsing algorithms. LR parsing, operator precedence parsing, those algorithms definitely we need to use, because normal shift reduce parser will fall into conflicts. What is conflict here? Shift is there, reduce is there. What you are saying here, both possibilities. I can reduce this. Reduce possibility is also there. Shift possibility is also there. Parser unable to decide. If both possibilities are there, reduce is also possible. Shift is also possible. Which one? For which I have to give priority. For that, we have to use LR. In that, tables are there. Tables are used. By using tables, we'll resolve these type of confusions. That the perfect technique to resolve these confusions is LR parsing algorithm, in which we have some tables. By using the tables, we resolve this. That we are going to see in the coming classes. Okay. So till this is the way of doing bottom up parsing. Bottom up parsing, the bottom up way of implementing bottom up parsing. Just let me revise once what we have studied in today's. Now today's session, we have discussed about what is the bottom up parser, the way of construction of bottom up parser from bottom to top, and derivation, rightmost derivation in reverse, and what is handle detection. This is a major concept. So all these are manual things. If you implement a program for this bottom up parsing, that program looks like a shift reduce parsing. So those programs are called as shift reduce parsers. What are shift reduce parsers? The parser that looks like this, it is having a stack, having input buffer, performing these following four operations: shift operation, reduce operation, we can say actions also, shift actions, reduce actions, accept, error. With the help of these four, whenever you are doing parsing, that is called as shift reduce parsing. Okay. So for today, just I am introducing the shift reduce parsing. That's all for today. And in the next class, we'll come with the LR parsing, the most powerful parsing in the bottom of parsing. That is LR parsing algorithm that we are going to see in the next class. If you have any doubts till now, you can ask me. Any doubts from your side till now, you can just ask me. we'll see the LR parsing concept in the coming class. Okay. Any doubts from bottom up parsing until now what we have studied? Today is just a basic introduction of bottom up parsing. Tomorrow we'll see the exact algorithm, how this LR parsing algorithm looks like. Okay. Okay, students. Okay, then just revise this before coming to the next class, and we'll discuss LR parsing algorithm, bottom up parsing in the tomorrow class as well. Okay. Thank you all. Have a good day. Bye bye. See you in the next class.